All right, so in this next video, as we continue to solve problems using trigonometry, we're going to look at the idea of simple harmonic motion. So if we've got a point moving on a number line is in simple harmonic motion if its directed distance d from the origin is given by either d equals a times the sine of omega t or d equals a times the cosine of omega t. Where a and omega are real numbers and omega is greater than 0. So the motion has a frequency of omega divided by 2 pi, which is the number of oscillations per unit of time. So use the word a couple times, but you may want to jot down a note. That symbol here, here, all these things. This is the Greek letter omega. You think of like the alpha and the omega. This would be the lowercase version of the Greek letter omega. So omega is often used in physics for angular velocity. Okay, so angular velocity is like how fast something is going, around a circle essentially, or traveling through a particular angle. So relating that way back to the first lesson in this unit when we were talking about one of our students hanging on to the outside of one of those windmills in Indiana and spinning around and around and around, that was their angular velocity, how fast they were traveling around the circle. So A is going to be amplitude here, which would be the distance that our whatever it might be is traveling. So for example, there's a piston. If you can imagine a piston, it's going to go back and forth here to there, to there, to there, to there, to there. It just keeps going in and out and in and out. Okay, so that's simple harmonic motion at work. It starts at 0 would be the middle. Its initial position is going to happen whenever t is equal to 0. So when I plug in 0, that's where that piston happens to be at time 0. It's going to travel as far as a to the right and as far as negative a to the left, so a being the amplitude. And then if you turn it on its side, it's going to look something like this when you graph it with respect to time, which would be our nice sine or cosine curve. Okay, so putting that into use then, we've got an example here where in a mechanical linkage like the one shown in this figure, excuse me, a wheel with an 8 centimeter radius turns with an angular velocity of 8 pi radians per second. So that would be our omega value. So if we want to put omega is equal to 8 pi, that would be good. It's our angular velocity. Okay. And then we're given a function that tells us, okay, 8 times the cosine of 8 pi t is going to determine where the x value is. In this case, where the d of the distance happens to be. Okay. So we're asked, what is the frequency of the piston in cycles per second? If you remember from the slide up above, frequency is equal to, we'll bring it back right here, omega over 2 pi. So whatever omega happens to be, we take that divided by 2 pi, and that's going to give us our frequency. So for this particular problem, omega, remember, was 8 pi, and 8 pi divided by 2 pi will equal 4. So what that means is this piston is going to make 4 cycles per second. Okay, per second. Which should make sense if it's 8 pi radians per second. Remember, 2 pi radians would be a full circle. So 8 pi radians in a second means we're going to go 4 circles, which would be 4 cycles. Okay, so 4 cycles per second would be our frequency. That's letter A. Letter B, what's the distance from the starting position t equals 0, exactly 3.45 seconds after starting? Well, to do that, we're going to use this function. D, the distance, or its position, is equal to 8 times the cosine of 8 pi t. Okay, so 8 pi being omega, 8 being the amplitude or the distance or the radius of the circle. That's how far out we are. So what we're going to do, figure out the distance from the starting position to that position. What I'm going to do is I'm going to figure out where I am at 3.45 seconds. Meaning if I plug in 3.45 in that function, what am I going to get? So I put d of 3.45, that's what I mean. I'm going to plug in 3.45 into this function for t. And then I'm going to subtract the d of 0, meaning where were we when we started? Okay, what is the position at time t equals 0? And then because I'm looking for a distance, and this could be a negative value, what I'm going to do is I'm actually going to take the absolute value of whatever number comes up here, okay? Because distance is always going to be positive. Another word that we might use to describe this would be its displacement. How far is it from where it was? Okay. Now to do that, the d of 3.45 and the d of 0, what we're going to do is we're going to plug in 3.45 for t. So I'm going to use my calculator to do that for me. So I type in 8 times the cosine of 8 pi times 3.45. And right next to it, it should be okay. That's going to mean multiplication in my calculator. Now I'm in degree mode right now, and for these examples where it's harmonic motion, that typically happens in radians. So I'm going to go ahead and change my mode so that I'm in radian measurement, as opposed to the degrees that most of the lesson was in. All right, so I'm good to go. I hit enter. There's my number, so 2.47-ish. Now I'm going to do the same thing. I'm going to bring back the previous entry, but I'm going to change t to 0. So 8 times pi times 0. Now I don't necessarily need my calculator to do this for me, because I know that 0 times 8 pi is 0, and I know that the cosine of 0 is 1, and I know that 1 times 8 is 8. So I bet that when I punch this in, my calculator gives me 8. Or at least I know why. Okay. So then I'm looking for, again, the difference between these two. So I'm going to be taking this 2.47 number minus, so I go up and select it, minus the previous answer, which is 8. I'm going to type it in. Hit enter, and I'm going to get a negative value, but remember, this is a distance, so we're just going to take this and make it positive. Okay. So when all is said and done here, we are going to have, for an answer, the distance between the starting point and the ending point is going to be approximately 5.53, and then the label we're working with is centimeters. So 5.53 centimeters would be the distance traveled, and again, that's 4 cycles per second was the answer to the first part.